Welcome back. I hope you all are doing good and learning the principles of air pollution and mitigation, some fundamental concepts on this one. So, in the previous lecture I discussed little bit about the optical properties, especially Beer-Lambert's law, and then it's one application that we use in aerosol optical depth. Okay. There are some of the things that I have to cover before I go more into the detailed of optical properties and its measurement. So, in this lecture what I am going to do, I am going to discuss the week 7 methods for measuring air pollution and mitigation, sampling techniques, offline and online methods. So, then in this part will cover the instrumentation. So, what are the instrumentation and which kind of instruments that we use, what should be the specification of the instruments that can be used for the measurement of air pollution and then related things. So, this is a very famous saying, why do we do measurements actually? So, Peter Drucker, that if you can't measure it, you can't manage it, this is very simple. So, if you want to manage something, you first need to measure it properly. Okay. So, if anything is not measured, it cannot be actually managed. This is very principle and very simple words, but they have a lot of significance. So, for example, air pollution management, when we talk about the management of air pollution, until and unless you know the sources, where they are coming from, what are the labels, whether they are at the higher level that they can impact on the humans and ecosystems or not. So, until we know these things, it becomes very difficult to manage. But then before you manage what? You have to manage air pollution, and air pollution is not a single term, it consists of many terms that are there. So, actually what you have to do, you have to measure the air pollution first, okay, and this is what I am going to discuss this one. So, you can only manage well if you can measure well. If I just add this write these sentences in this way, that we can only manage well if we can measure it well. So, this means here the wellness means that well means we need to have a highly accurate and precise data. This is actually very fundamental. So, now it depends on what kind of accuracy. It is actually based on your application. You can define that what level of accuracy and precision is needed actually, whether we really need a 5% precision and accuracy, or we need 2%, or we need 10%, we can or even we can sacrifice with the lesser accuracy and precision measurements. But this is very important. So, we have to first put this in perspectives, that we have to get a accurate and precise data, and this is one of the most problem that we don't have actually. And then the second thing is that, is only monitoring or measuring enough for management of air pollution? I think no. The very priority, and that's I have been discussing, the first priority should be measuring well and how the good quality data we have. So, we need to have quality data with good precision and accuracy, and as I discussed, that precision and accuracy you can decide, or we can decide, depending on what kind of level of things that we are having. This is another very important thing. Measurement actually, when we say what is measurement, so before you have to measure something, so you have to come to the measurement part. Now, measurement is the hardest part of doing any research or any management. So, if you are either doing research or if you are doing a management, this is the hardest part, and many of us who are a kind of atmospheric chemist. They put lots of hands gloves together, and then they dirty things like collecting the samples from all the places, especially people who are working on the wastewater treatment and water technologies. They go and measure. We also work in a very highly kind of polluted environment, so that is also a very difficult job, and sometimes you have to work in very harsh conditions, very cold, and if you are true researchers, you might have to go to remote places where you don't have anything. People go to the ocean, they collect samples and they do the measurements. So such kind of things, air quality, we go into in the Himalayas, they collect the samples, snow samples for example. It's pretty cold there, so still you have to do. So this is because this involves lots of effort. It's not a kind of white collar job. By sitting on the computer you can just do everything. You can't do. You have to first collect the samples before you start measurements, if it is offline. If it is online measurements, then still you have to go and set up the laboratory there. So we will see when we begin operationalizing concept about this one, that why it is the hardest part. And this is, it might seem very easy, trivial or even boring, but this lecture, but I think measurement is really very important, and you will realize this in coming things, in coming few slides or lectures. So measurement again is the most important and foundation of any scientific investigations or part of research. Everything that everything we do, it begins with the measurements of whatever it is. Okay. So anything you start doing, especially in the research, it starts with the measurement, or at least having some idea about the data, because measurements will give you the data. So data will come to, when we come to the data, then we will discuss those things in detail. So there is another very important saying, that fancy statistics and poor measurements are a problem. It's like there is another saying, I don't want to see this one, but if you just see this one, garbage in, you will have a garbage out. Okay. So if you are doing any kind of, whether it is a kind of computational or research, if your sampling is not proper, or samples are not homogeneous, or samples are not collected from a proper locations, then your data that you are generating actually is kind of the samples, bad samples you have already, and you did all the analysis, and then finally you got some results, and oh, how come it is possible? It is not possible. I am getting something seriously, something wrong results here. So this is actually very much problem. So collecting a kind of we will see this one, homogeneous samples is very important. You have to collect homogeneous samples. You have to collect from the right location, right height, where you have to collect, and what substrate that you use. Filter matrix, this is also very important, that what you are going to use, this is very important, that where you are going to do this one. So there are two things actually. There are two terms that we often hear, one is measurement and other is monitoring. So are they same or are they different? They are not same actually. So measuring is defined as to ascertain the size, amount, degree of something, whatever parameter or physical quantity you use, by using an instrument or device marked in a standard unit, or by comparing it with what an object is known. So measuring actually is kind of to ascertain some physical quantity. When you are doing, I am doing some measurements, actually you will be doing some measurements of some physical quantity. We will come to that one, that we have two type of measurement actually, like so we will discuss those things in detail, but just remember, measuring is something that to ascertain, I mean to get the really idea that okay, this is, I am getting these things. Okay, so these things you have to remember this one, and think of monitoring as a collecting data about things you can't directly measure. Monitoring could be something else. Okay, For example, it is not very kind of actual data, or you are not ascertaining something, like customer perception of satisfaction. One of the things is actually like, whether the data is actually like, whether the customer is satisfied with the product or with the service that you had, that is, you are actually collecting some information or collecting some data. Okay, so monitoring is something like that. Here if you just say monitoring is first thing, and then measurement is the ultimate final results that you have actually. And there, because the measurement, if you just see this one, so as I told that measurement, and we discussed this one, and I have discussed this in previous slides. So poor quality measurements can lead to the poor results, and finally poor management. And when, for example, here when we say quality, what quality means? When I say quality could be anything actually, but here we are referring to quality is like, air quality. Now air quality, it's actually could be quantitative or as well actually qualitative. So you have in the measurement part, there are two types of things. Okay, so for example, when I say I am monitoring air quality, I may be sitting somewhere and just realizing that how many vehicles are passing, and then by looking at the environment, and I am saying that okay, the air quality is good or bad, or we are putting some kind of inference with the instruments which is giving only qualitative data. Okay, so then you have for example, in air quality you can have both are quantitative terms and has to be converted to the quantitative terms. Here the problem is quality and air quality, both are actually like quantitative. So quality can be qualitative, but when you say air quality, you are putting some numbers. For example, air quality index. Okay, so air quality index, when you say, then air quality index becomes a number, it becomes a quantitative term. So you have to report this in numbers. Okay, the issues here is that air quality calculations, for example, the NCAP, National Clean Air Program, they suggested that based on the air quality calculations, we are planning to reduce the air quality, or we want to make the air quality better by 20 to 30% by reducing the air pollution. So compare, now you have to reduce means you have to compare with something. So baseline was set up as 2017. So the idea is that NCAP says that we want to reduce the pollution levels by 20 to 30%. Now 20 to 30%, when you say, this becomes a quantitative terms. Okay, but otherwise I say we just want to reduce the air quality, enhance the air quality, we don't give any confirmative numbers, then it becomes a kind of qualitative data. Okay, so unlike monitoring, measurement can be defined as the acquisition of information. Okay, it's an acquisition of information about a state or a phenomena. Here actually the object of state or phenomena, here the object of measurement will be there in the world around us. So wherever you are measuring actually, so you have to acquire information about the state or phenomena of the object that you are actually trying to measure. Okay, this means measurements must be descriptive. This what very important sentence, that it must be descriptive, means it can be described. Okay, and not only described, it must be observable. You can only describe if you can observe this one. So it has to be observable. With regard to the state, again state here means the physical state or the object we are measuring. There must be a relationship between the object of measurement and measurement results. So this is very important. We will come to this one in few minutes. Just wait here. So when I say, there are three very important criteria for a measurement. The first one is like, it has to be descriptive. Okay, if you want to measure something, the first thing that the physical property you are going to measure, it has to be descriptive. So the descriptiveness is a necessary but not sufficient. This is also very important. It is necessary, it has to be descriptive. If it is not descriptive, it cannot be measured. So, but it is not the sufficient aspect of measurements. Okay. For example, when one reads a book, one gathers information but does not perform a measurement. Okay. So, when you are reading something, you are gathering the information. So, basically you are some sort of, if you say that you are monitoring, okay, you are gathering some information but you are not performing any measurements. But if you are a student, you are reading a book or you are attending this lecture, you are gathering some information, and when the exams will be conducted, then the output will be actually measured. So, how many marks question was there and how much you have achieved, then it can be actually, then it becomes a measurement. So, monitoring and measurement. So, first it has to be descriptive. Second aspect of the measurement, it has to be selective. You can't measure everything, okay? It has to be selective. It may only provide information about what you wish to measure, okay? Or this actually is also called measurand, you know. So, you have to be selective. For example, one physical property can be measured by more than one techniques, more than one properties. But which one has to be used, you have to be selective there. So, you have to select that, okay. So, then what we wish to measure is actually measurand, and not about any other of the states or phenomena around us. So, selective is very important. So, first thing, it has to be descriptive, second it has to be selective, and third and sufficient aspect is that the measurement has to be objective. This is very important. Here the objective means the outcome of the measurements must be independent of an arbitrary observer. So, whatever the outcome is there, it should not be dependent on whether I am measuring or you are measuring or any third person is measuring. So, all the persons should be getting the same result, they should not be getting the same different results, and that is why it is actually, it has to be objective. So, descriptive, selective and then objective, these are the three very basic criteria for any measurement to take place. There are two types of measurements, one is actually active measurements and then other is actually passive measurements, okay. In the active measurements, you have some reference, but so this means actually when we are doing something, you have to measure first, there has to be a reference. Without reference, you cannot do anything actually. So, first you have to define a reference, or sometimes we call it actually baseline. Like if you remember in the previous lecture, in the previous slide, I talked about reduction of air quality index, we have to improve 20 to 30% with respect to which time period. So, this is actually 2017, this was the NCAP mandate, okay. So, as per the NCAP mandate, we have to enhance our air quality or reduce air quality index by 20 to 30%. Now, 20 to 30% of what? When it comes actually 20 to 30% doesn't mean anything until and unless you define the baseline or you define the reference. So, the reference is here 2017, okay, and so there you have a reference and then you have a measurement object, and in this system what is done actually, the ratio measuring system active, so you provide some active information, okay, that the object already had. So, here the object need not to be given the energy actually, okay. So, then using the ratio, you have to define that y is actually what is the relation between the xi and xr. So, you may be actually y can be defined as xr divided by xi, sorry xi upon xr, because it is xr is reference will be down. So, this is a ratio system. So, same thing, you have some difference and then you measured something, you measure the same object. For example, you are measuring the absorption, okay, absorption or emission, you have to have the reference first. You do not have the solution, absorption in a solution. So, solution you basically prepare a reference, there is nothing added in that, no absorbing species is present, and then you measure the absorption when the measurement is absorbing is present. The passive measurement, the second one is actually passive measurements. In the passive measurements, what is important here, you have to add an exciter here. This, whatever the object you are measuring actually, it will not directly provide the information, it will not provide any information. So, here the object does not have active any active information. This means somebody has to tell, the active information has to be given to that, otherwise it cannot be done, and then the rest of the things becomes the same. So, there are two types of analytical measurements or classification of analytical measurements or methods. So, if you want to measure this one, there are two types of analytical methods. One is actually like qualitative and other one is actually quantitative. So, you have qualitative and quantitative instrumental analysis. Qualitative instrumental analysis is that measured property only indicates the presence of analytes, okay. So, it just say that there is actually some analyte is present. For example, when you are doing some kind of acid base titration, or you are using the litmus paper test, you are doing measuring the pH of the solution, trying to infer the pH of the solution, there will be just change in the color of the litmus paper or the solution itself, whatever you are doing. By doing this, you will be, for example, be able to know that whether the solution is basic or acidic. You can get this information, but it will not provide that what actually is the pH value of that solution. So, you will not be able to do this one. If you are using a litmus paper, it will provide a basic and acidic information, and it will provide a kind of range, that probably this could be in this range. pH could be between 4.5 to 5, but it will not give exactly that whether it is 4.4, 4.6 or 4.8 or 4.9. It will not give, it will give a range. So, this is actually kind of qualitative information. The second is actually quantitative instrumental analysis, and in this the magnitude of the measured property, or in the previous slide I said it is called measurand, is proportional to the concentration of the analytes. So, the proportionality could be directly or inversely, both ways could be there, okay. It could be directly or inversely. This becomes very important, and in order to get the quantitative analysis or quantitative data, one has to measure it actually. There is no other alternative. You cannot just get this information, quantitative data, without measuring it. For example, use a pH meter to know the exact value of pH of a solution. If you want to know the pH of the solution, you have to usually use a pH meter, okay. And then here, then the third, if you remember third part, it was actually like selective. So, here for example, you have to define what you want to measure. Solution is there, in the solution what you want to measure pH, okay. Then I said descriptive, objective and selective. So, selective, you have to first selective and then objective, okay. So, you have to be selective, what you want to measure. So, species of interest you have to define. All constituents of the including analytes and matrix analytes, i.e. a component that naturally accompanies or follows something. Contaminants, for example. So, all the contaminants, there are so many contaminants in water, for example. So, you have to define which species of interest you want to measure. Otherwise, you will, so until and unless you define that species of interest, it will the measurement has no value. So, you have to be selective, okay, and objective here. For example, but here what is happening, because in the solution there are many more than one contaminants. So what is actually happening here? If you have to measure something, you have to sometimes do the pre-treatment as well, and this pre-treatment can be done by chemical extraction, distillation, separation, precipitation, and many more. There are many techniques, but this is I think beyond our scope. For example, if you want to measure the air quality, you have to collect PM 2.5. So you have to actually only collect PM 2.5, not. So you have to actually do kind of cyclone and other things. Okay. So it has to be selective. So once you have done, you have to first define your species of interest, which species you want to measure, and then you have to also define that how low you want to measure or how high you want to measure, what is the lowest value that you want to measure. So basically you have to define least count. So based on this one, you will define which instruments to use. Okay. So I think what is important here, we just gave some idea about the measurement, why measurement is important, what are types of measurement, what is the criteria or characteristics of a measurement, what do you mean by the species of interest, and why are we interested. In the next lecture when we come, we will discuss these things in further details. So till then, take care and bye bye.